I've got it as y equals 1 minus x squared. I would not want to put 1 minus x squared here because then I've got an x, I've got a y, and I've got y boundaries. I have to solve this for x so that it's in terms of y. So solving this, I will add the x squared over here and subtract the y. So x squared, add, I get 1 minus y. And then instead of taking the square root, I'm going to raise to the 1/2 power on both sides because that's easier to integrate. So x equals the quantity 1 minus y to the 1/2 power. So I'll put that in for my r, 1 minus y to the 1/2 power, and I've got to square the radius. So I have to take this whole thing and square it. That's actually a good thing because I get to multiply my exponents together, and that'll bring it down to a 1. So from 0 to 1, pi, I'll have 1 minus y, just to the first now, because 1/2 times 2 is 1, dy. Okay, you've got a couple ways to integrate this. Because this is a power of 1, I can just distribute the pi, or I can pull the pi out in front and integrate each term separately. Or I can do a power rule where the inside, the derivative is -1, and then add 1 to the exponent. There's a couple ways to do this one. I think it's easiest to just distribute the y and then integrate each term. So before I integrate, I'll distribute the pi. So that'll become pi minus pi y dy. And now I can integrate each term. So that's just a constant. It's like 3. To integrate that, it's pi x. And then here, not x, but a y. Sorry, pi y. Because the derivative here would be pi. And then here I add 1 to the exponent. So I get pi y squared multiplied by the reciprocal as a 1/2. And then evaluate from 0 to 1. Okay, putting in a 1 for the y, that'll be pi minus 1/2 pi. Putting in the 0, I get 0 minus 0 is 0. So pi minus 1/2 pi is 1/2 pi. Didn't need a calculator on that one. So put in 1 for the y, pi. That'll be 1, 1/2 pi, subtracted, got a 1/2 pi, 0, gave me a 0. Okay, let's try one more. So you find the volume of the region in quadrant 1. Volume of region in quadrant 1 for y equals 8 minus 1/2 x rotated around the x-axis. All right, graphing first. Oh, let's see. Yep. 8 minus 0.5x graph. The linear function. Okay, there's my 8 minus 1/2 x. I'm going to take this and revolve it around the x-axis, and I can see I'm going to get a cone shape there. Okay, so first I want to start with my rectangle, and because I'm going around the x-axis, I want my little rectangle to be perpendicular to the x-axis. That's going to spin around here, making my cylinder. Now I know I've got my width here as a dx. That's actually my height of my cylinder. But at least it tells me what variables I need. I need my equation in terms of x, and it is, so I'll leave it like that. I need x boundaries. I know this one's 0. I've got to find this one. So I know at this point, I don't know the x, but I know the y is a 0. Because there's no height there. So if I put 0 in for the y, put a 0 here, and then solve for x, I'll subtract 8 divide by negative 1/2, that's going to give me 16. 16 halves in 8. So I know my boundaries are 0 and 16. So the volume then will be the integral from 0 to 16. This is going to be a cylinder shape. That formula is pi r squared h, so it's pi. The radius of each cylinder is determined by this equation, because it's minus 0, because that's 0 down there, that horizontal line. So that's 8 minus 1/2 x. I've got to square that radius, and the height is dx. Okay, this time I think I'm not going to FOIL it out. The pi I'm going to pull out in front, so it's not in my way. I have an inside to a power. I need the derivative of the inside attached to the dx before I can do that power rule. Well, the derivative of the inside is a negative 1/2. So if I put a negative 1/2 here, timesing by a negative 1/2, I got a times by a negative 2 out here, and then I can do power rule. So that's a negative 2 pi that's going to carry along. And now power rule here. The inside is 8 minus 1/2 x. Add 1 to the exponent, multiply by its reciprocal, and then I'll evaluate from 0 to 16. Okay, so let's see, y equals, that'll be a negative 2/3 pi, negative 2 pi divided by 3, 8 minus 0.5 x quantity cubed, and I want to start at 16. So if I put in the 16, I get a 0, minus, did I put the negative in? Oh yeah. Now I want to put in a 0, table set, 0. I get a negative 1072.33. So subtracting a negative, I get 1072.33 cubic units. That's right. And oh, I forgot, the book also asked you to use the function integrate. So what I can do before I did my integrating thing here, I can do the function integrate as a check of this original equation that I put in here. So let's review that. Go to calc, down to function integrate. Oh, where is it at? Is it under math? Math. It's been a while. There it is. It's under math. Function integrate. Oh, I don't want it there. Jeez, I might get this right. Math. Function integrate. Okay. Start with my original equation before I integrated it, because the calculator is going to do the integrating. I had a pi, parenthesis 8 minus 0.5 x raised to the second power. Oops. Comma. X. Always the letter you're using, and then the boundaries. 0 to 16. And I get the exact same answer. I think the part B's asked you to check the function integrate to check your answer anyway. But it's I put in the pi, 8 minus 1/2 x quantity squared, comma x, comma 0, comma 16. So it's your equation here, always an x, and then the boundaries. Okay, so we're doing volumes of solids, doing cylinders today. Each day there's going to be a new shape, which makes it more challenging. So not too bad if you keep everything straight. You are going to do page 8. page 389. Quickies 1, 2, and 3. Oops, 1 through 3. And then 1 through 5. I think it was 1 through 5. Let me double check. Yes, 1 through 5. Okay.